Now this is a question which came from the topic time and work. Even in the year 2023, a similar kind of question came, but that was a little bit more harder. Now let's see how this problem will go. X, Y, and Z can complete a piece of work individually in 6 hours, 8 hours, and 8 hours. That basically means that, let's note it down. X needs 6 hours to complete the work. Y needs 8 hours to complete the work. Z needs 8 hours to complete the work. Now, just by looking at this, try to tell me who is more efficient. In fact, if you want to hire someone for completing the same exact work, let's assume the quality is exactly same, then whom will you hire? Of course, you are going to hire Mr. X because he only needs 6 hours. The other people will take 8 hours to finish the work. Okay? Now, this is the time we have to define one more thing. That is, when time is less, that means his efficiency is high. His efficiency is high. That is why you want to hire this person. He is able to do more work in less time. Therefore, let's assume that everyone is doing only one work. How much work? Everyone is only doing one work. Let's say, for example, the work is building a Taj Mahal. Okay, so they are doing one work. Now, according to this condition, if this person needs 6 hours to work, okay, to finish one Taj Mahal or one work, that basically means in 1 hour he will be doing 1 by 6 or 1 by t work. Why? Because first hour he'll be doing 1 by 6, second hour he'll be doing 1 by 6, third hour he'll be doing 1 by 6, and just like this, first hour, second hour, third hour, fourth hour, fifth hour, by 6 hours he'll be doing 6 by 6 or one work. Therefore, whenever we have time, we can easily find the efficiency by doing 1 by t. Efficiency is equal to 1 by t. So, efficiency or the work done in 1 unit of time. Here it is in 1 hour. Work done in 1 hour will be 1 by 6 for X, 1 by 8 for Y, and 1 by 8 for Z. Now let's go back to the question. However, only one person at a time can do a work in each hour. In each hour, only one person can work. Nobody can work for 2 continuous hours. All are engaged to finish the work. What is the minimum amount of time that is required to finish the work? So even they want to finish the work in the minimum time. If you want the work to be finished in the minimum time, the person with highest efficiency, that means X, his 1 by 6 is much bigger than these two values. So the person with highest efficiency should work more. So let's see how to solve this thing or how much time they will be taking this to solve the problem. So I want the work to finish fast. So the first person whom I'll ask to work in the first hour, X will be working. He will do 1 by 6 of the work. But after 1 hour, he will get tired because the question says that no one can work for 2 continuous hours. It's mentioned here, 2 consecutive hours, no one can work. So in the second hour, I can hire anyone, Y or Z, because both of them have the same efficiency. Let's say Y, okay? Then Y will be doing 1 by 8 of the work. Now let's see how much work has been completed. Starting, nothing was done. Then X came and did 1 by 6 of the work. Then along with that, 1 by 6 of the work is done. Then Y also did 1 by 8 of the work. Now if you add this thing, okay, what will you get? Let me add that thing. 1 by 6 plus 1 by 8. To simplify this, I'm going to take 2 outside. So 1 by 6 will become 1 by 2 into 3 plus 1 by 2 into 4. If I take 1 by 2 outside, I'll get 1 by 3 plus 1 by 4. And that is going to be 1 by 2 into 4 plus 3 by 3 into 4, 12. That is 7 by 2 by 24 or 2 into 12. 7 by 2 into 12, that is 7 by 24. So within the next 2 days, in 2 days, 7 by 24 work is done. Okay, so let me mention it over here. For in the 2 days, 7 by 24 work is done. Now again the work 2 days, 2 hours, and the work has to be completed very fast. So in the third hour, X have taken enough rest. I'll even hire X back. So X will again do 1 by 6 of the work. Then the fourth hour, I'll take Y or Z. You can take anyone because both of them have the same efficiency. 1 by 8, he will do another 1 by 8 work. So you see, if you look at over here, if you look at over here, in the first day, in the first day, in the first 2 hours, this much work has been done. 1 by 6 was done by x, 1 by 8 was done by y. That is 7 by 2. In the third and fourth hour, or the second 2 hours also, these two people will be doing, x will be doing 1 by 6 and y will be doing another 1 by 8. We have already added this value. That means in the second part, again 7 by 24 work will be done. So starting 7 by 24, next 7 by 24, total work done will be 7 by 24 here. After on the fourth hour, the total, after the end of fourth hour, the total work will be 7 by 24 plus 7 by 24, 14 by 24. Okay. Now again, I will bring back x. So fourth hour, fifth hour, I'll bring back x. X will work and do 1 by 6. Right, sixth hour, I'll be bringing x, y or z, anyone, not x. X you need to rest. Let's say y. He will do 1 by 8. Again, if you see, 7 by 12 work has been done in this gap also. Okay, you can simply add that 7 by 12 work to this thing. That is 14 by 24 plus 7 by 24 will become 14 plus 7 by 24, or 21 by 24 work was done. Okay, now if you look at this value, this is much more closer to 1. It is not yet 1. Little more work has to be done. The total work that has to be done was 1. And after 6th hour, 21 by 24 work has finished. Now how much work is left? 24 cross multiplication, 24 minus 21 by 24. 3 by 24 work has to be done. 3 by 24, if I simplify, I'm going to get 1 by 8 work has to be done. Okay, so only 1 by 8 work has to be done. But again, I have to finish the work as soon as possible. So in the next hour, I don't even need the next full hour. After y, x will come back again. His efficiency is 1 by 6. And he doesn't have to finish 1 by 6 work. He only have to finish 1 by 8 work. For this, I need to find the time. Okay, how to do that? There is a formula for time and work. Okay, it goes like this: work done is equal to time into efficiency. In fact, efficiency, you just look at this. If efficiency increases, more work will be done. If time increases, more work will be done. Or any such thing which can increase the work will come over here. For example, some things will be there where multiple people are working. N number of people, more work will be done. So N will come here. More time, more work will be done. More efficiency, more work will be done. Number of people into time into efficiency. And also hours worked per day. More hours worked, time efficient work will be done. So I can write whatever increases the work, I can write in one go and multiply them. Just multiply that with efficiency and you will get the thing. Here anyway, number of people are not there, only work done and time and efficiency is there. So if you look at this case, how much work has to be done? 1 by 8 work has to be done. Efficiency, I have to find the time. Efficiency of our x is 1 by 6. That basically means taking the 6 to other side. 6 by 8, simplifying that will become, divide 2 by both sides, 3 by 4. 3 by 4 hours are required. Okay, so the time required by x to finish 1 by 8 of the work is 3 by 4 hours. I'll convert that into minutes. Simply change 1 hour is equal to 60 minutes. Okay, if you do it, you will find it is 15 into 3, 45 minutes. So x only need 45 minutes to finish the work. So the time required will be 45 minutes. So how much is the total time? 6 hours and then another 45 minutes. 6 hours, 45 minutes. Answer is C. In this question, I have taken the total work to be 1. Now there is another one approach to do time and work problem. Again, let's see that approach also. In that approach, what we will do is that, see, it is given that x needs 6 hours, y need 8 hours, z need 8 hours. First thing which you have to do is that we have to find the LCM of 6, 8 and 8. 6 is 2 into 3, 8 is 2 cube, and this is the same number. So LCM is gonna be whatever is common, take the highest power, 2 cube into 3. This is LCM. Okay. If you do it, it is going to be 8 into 3, 24. So yeah, 24. Okay, in this method what we'll have to assume is that the total unit of work which has to be completed will be 24. Okay, that is the first assumption. And let's see the total work. Total, this is the total work that has to be finished. Now it is saying that X needs 6 hours to finish the work. So here also we have to see X will finish, time into X is equal to work. For finishing 24 work, X need 6 hours. So the efficiency of X will be 24 by 6. What is 24 by 6? 4, I guess. Yeah, it means X in each 1 hour, X will do 4 units of work. So 4 units of work in 1 hour. So the efficiency of X will be 4 units per hour. Similarly, Y will need 24 by 8, and that is he will finish 3 unit per hour. Z also similarly 3 unit per hour. Now we can again solve the problem in the exact same method. That basically means that total work which need to be completed is 2 hours, and the work has to be finished as soon as possible. In the first hour, I'll be hiring X because he is doing more hour per hour. In the first hour, let me write it a bit down. In the first hour, I'll be hiring X, and he'll be doing 4 units of work. I need to finish 24 hour. Okay, this is the work done. Work done individually. Total work. 4 units of work has been done. Then in the next hour, second hour, I'll be bringing in Y. He'll be doing 3 units of work. So total work done is 4 plus 3. 7 units of work has been done. In the third hour, I'll bring back X. He'll be doing another 4. That is 4 plus 7. 11 units of work has been done. In the fourth hour, I can bring anyone, Y or Z. I'll bring Z. He'll be doing 3 units of work. That will be 14 units of work will be done from the starting. Then again, I'll be bringing back, in the fifth hour, I'll be bringing back X. He'll be doing another 4 units of work. So that will be 18 units of work has been done. I have to achieve 24 units. Again, on the sixth hour, I'll bring back Y or Z, anyone. He'll be doing 3 units of work, and that will put the work to be 21. Total work done is 21. Now only little more work is done. Total 24 work has to be done. 21 work has already been finished. Someone has to come and do 3 more work. So to do that last 3 works, we'll be bringing in X because he is faster. We have to find the time. That is time into efficiency of X is equal to work done. 3 is equal to X is efficiency of X will be how much unit? He does 4 units per hour into time. So time will be 3 by 4 hours. And again, that is 3 by 4 into 60 minutes, which is 45 minutes. So we need 45 minutes. So 6 hours plus 45 minutes. Therefore, the total time here also will be 6 hours 45 minutes. You can follow any method. Even though this method looks easier, there are some time that you might get stuck or confused over here. I actually prefer this first method. Yes, I know many people doesn't like fractions, but learning this method is a healthier way of doing this stuff. Okay, because there are places where only this method would work. In this case, thankfully both are working, but there are some places where only this method will work. Anyway, so answer is again C. Thank you.